so many things about the data, panel data, what is the regression, what's its application, and the hands-on experience and examples also. Maybe they will have further questions, but through your PPT and further session, they would be able to learn more things in future too. Thank you, ma'am. On behalf of
Thank
Jammu
you
and
so
Kashmir Economic Association.
Now we are moving to our second session of today, and it will be moderated by Dr. Jaskaran Singh, who are assistant professor at Ramgai College, Fagwara, Punjab. Dr. Singh, I think, is only the moderator who attended almost all the sessions of the workshop. Thank you, Dr. Dr. Please, over to you, sir.
Let's start. Okay.
can be multiple ways. I will show you each and every way. One small way can be like this, that I can drag down my Excel file. I can open data in my EVIEWS, or the best way, I can import the data in my EVIEWS. Importing means I will just go onto the files here. Here is the import. I will just click on the import, and I will just give the location. Usually my all the files are in my desktop, so I will just open the file from here. Now this kind of screen will be available. You just need to press the next. We are going to skip the first row. First row is skipped. Then we are pressing the next, again next, and our all the variables will appear now. Here my all variables are appear. You can see over here, for example, import. Simple. My all variables are over here. It will show you the interference as like the Excel files. You can see here the cell, and my all variables are here. Now, I told you the time series data is changing over the period of time. Time series data changing over the period of time. So I can show you small different thing. Here my all variables, I just collect my variables, open as a group, and here I am going to show you the normal line symbol graphs. Okay, and take graphs, multiple graphs here. Please confirm if you can see the graphs.
Yes, visible, sir.
Yes, yes.
Okay, so see, my all variable graphs are easily available here. Okay, and you can see here with the time, down is the time, on the y-axis, on the vertical axis, I have the values. Okay, down I have the period. With the period of time, the variable is moving forward and variable is changing over the time. So that's how I can see my all variable. If you want to see all the variables in like how you can say like a single graphs, so we can also see all the variables in a single graph. How I am going to show you in a while. Okay, so let's suppose this is my import. Okay, this is my import variable. I will again go view. I will click on the graph. I just check the line and symbol, and now this is available as like a single one, as like a simple one, import graph. So that's how I can easily check my all the graphs. Now let's proceed further. There is a lot of multiple options from the EVIEWS. For example, if I want to check any kind of descriptive statistics. What is the meaning of descriptive statistics? Descriptive statistics means like this, that the EVIEWS will show us the parameters. What is the meaning of the parameters? Parameters means different kind of properties of the variables. Which kind of properties? Properties mean what is the highest value in the variable, what is the lowest variable in the variable, what is the distribution, like it is a normal distribution or it is not a normal distribution, what is the standard deviation of the variables, what is the skewness of the variable. So EVIEWS can also show us the different kinds of properties of the variables. Let me try to open different kind of variables for different kind of values for you. Allow me a moment. So how I can do this? Okay. So let's suppose I select my all the data. Here is my all the data. I open as like a group. I will just go to the group, descriptive statistics, individual samples. Here I can see all the properties of my data. For example, mean. What is the mean of INT variable? What is the mean of inflation variable? What is the mean of industrial variable? What is the mean of import? What is the mean of export? What is the mean of ERV variable? What is the import of domestic rate? So here mean, median, maximum value, minimum value, skewness, kurtosis, Jerkabera, probability, sum of square, and number of observation. So that's how I can have all the properties parameters of my data. Now, let's proceed further. I have all the parameters of my data. Now, the first thing is that what I have to do, I have to check the unit root analysis of my data, which is quite easy. What I have to do, I will just select my one variable, which is domestic rate. I just selected. I will just go into the view. From the view, I just select the unit root. I will just click on the standard unit root test. Here, I am not going to change anything. Test type, here I have different kind of test type. Augmented Dickey-Fuller, Dickey-Fuller GLS, Phillips Perron. Usually researchers using augmented Dickey-Fuller. So I will just click on this and okay. So now it is showing me this kind of values. So here I have a values. Here I can see the probability value, which is 0.06, which is less than 10%. So now it's all depend on us. Either we are going to select our probability values at 5%, 10%, or even at 0%. Hello?
Yes,
we are
sir.
with you.
Okay, so you can see my screen. It was just disappear. Okay, so now here I have my values, which is 0.60. So my rule of thumb is like this, that usually most of the researcher, they are taking the values less than 0.06, 0.05%. So here I am just going to change some dimensions. Now I am taking its unit root at first level. Here I have a different levels, at level, at first different, at second different. So from here I select the first difference, and now its probability value turn at 0.001. Here I can show you how usually we researchers, whenever you are calculating it, how you can just make your table. Let's suppose here I'm taking 5 columns. Here I take 10. Here I just taking variable. This is my variable. Here I take first different. Here I am heading first level. Here is first difference. First difference. Okay. And here I am saying level of integration. Okay. I can delete from here. This column, I don't need this. Okay. So here I have domestic credit. So here I am just going to put in my Excel file. This is domestic credit. Okay. And here I am just going to put it value. For example, first I check domestic credit. Ah, here is my domestic credit level. First we are checking at level. T statistic is this, and this is the probability value. So what usually we do, we are just going to note down our values here at level 0, 2.823, and its probability value 0.0623. Here I am putting the values. But rule of thumb is that usually we go for 0.05%. Now I just converted into 5%. So now at first difference, my value is 703 divided by 0.000. So order of integration here I have at first level. This is my first result for first variable. Let's proceed with the other variables. Same thing. I'm just going to close my this one. Now, other variable. This is my other variable. Same thing. Go to the unit root at level. And this one is stationary at 0.00 level of significance. So again, I'm just going to write EVR, okay, ERV, which is minus 9.230, and it is 0.000. And here I'm not going to take in the first difference because it is already stationary at level. So my order of integration is at level at 0. Now, same next variable I'm going to take.
Excuse me, sir.
Yes, yes, yes.
I'm really sorry to interrupt in between, as I know that question answer session is at the last, but I personally feel that this entire discussion is based on the first and second difference. So it would be better. Can you please explain at least what's the meaning of this first order difference and second difference?
Okay, sure. I can explain you. 1 minute. Okay. Let me just show you from the uh, from here graph. Can you see this graph? Please confirm.
Yes, sir. I can.
Yes, sir.
Okay. So if you will just check this graph, you can see the movement. The movement of variable is for the 0 at level 0, and the movement is quite balancing. Whatever it is going up with the same frequency, it is going at 0. The movement is how you can simply explain. The movement is in a very much balancing form. Okay, so for this variable, even I can see the data, I can predict it. The movement among the mean is highly balanced, like it is moving in a balancing way. So its integration at level. Like it is not moving away from its path. It's not moving away from its mean. But if I will select any other data, for example, now you can see how this data is look like. Highly data is variable is falling down a lot, then variable is going up a lot, then again fall down a little, then again up, then again moving upward direction. From here to here you can see it's moving to the upward direction, then little fall, then again upward direction. So how you can simply say like this: the variable is drifting away from its mean a lot. It's meaning like this, that the variable is going upward direction, then it's not feeling a lot to the downward direction. So this kind of data, we can simply say that this kind of data will become the stationary. Stationary mean like this, that if we want to make this time series in a balanced way, so we have to take the first difference. What is the meaning of first difference? Meaning of first difference, like in a mathematical way, we can simply say like this, that if we want to make this time series in a balanced way, so we will take plus and minus, making a difference at every level. So this kind of data will be adjusted, will not have any kind of unit root issue at level 1. So this is the major difference. So that's why I just show you the graphs, all variable graphs initially. Here we can simply say, simply see, like this variable, we can see that this is the mean value, this is the zero value simply. So we can see the variable is moving in around its zero mean in a very balancing way. This one we can also say it is moving somehow in a balancing way. Okay, this one is also, but IND is not moving in a balancing way. IMF, it's not moving in a balancing way either. And that's also interest rate is not moving in a balancing way. So while seeing the graphs, we can predict this. Yes, there is also a question. Yes, please. Can you please explain the meaning of the level first and the second difference? Okay, so I just explained the meaning of level is that when the mean is not drifting too much from its mean value, from the center value, this is the meaning of level. When mean is drifting uh, from its central point with the difference of 1, this is the first level of this difference. And when the mean is mean is drifting a lot from its mean value, so this means the second difference. So here we can easily see from the variables are drifting a lot from its mean values. Now let's proceed to the other. I will give you the example here. For example, unit root. So see, even at the level, there is a issue of stationary with this kind of time series. And when I will check the graph, I can even see here. See, the values have entirely upward direction. All the values are growing upward, falling not too much, but at after 2020 it falls a lot. So it have an issue with the unit root. So now what I am going to do, I'm going to check whether it have issue at first difference or not. Unit root standard, even the probability value, even if the probability value is not less than 0.05 at first difference, I think this time series will be stationary at second difference. Yes. So we can see this time series is stationary at second difference, not even at level, not even at first difference, and it's going to become stationary at second difference. Here we can see, even from the graph. Here. So now I can even take my other variable, which is export. I can check first is graph. So I can see over here, its values are falling down and going upward direction, but in a quite balancing way. But still, I can predict. I have to check that what is the level of stationary over here. I'm just going to the unit root. I'm checking at level first. No, it is not, because probability value is higher than 0.05. So I am going to select first difference. Yes, it's become stationary at first difference. Probability value is 0.05 at first level. So I can note down this in my chart also.
So we can
Yes,
understand it, through graphical, diagrams. We are easily understanding that the central point, the mean, if the
exactly.
if the data is diverting more enough, then we can say it is having stationarity problem. But while checking with the data, we have to compare it with the probability value. If it is more
Exactly.
than, if it is more than 0.05, then we can say it is not at a level. But if it is under, then we can say whether it is at level, at level, or first difference or second difference. So
Exactly.
her question was that how we can understand whether what is level and what is first difference and what is the second difference. But
Okay.
theoretically we understood that if it is diverging from the mean more enough, just like we was visible for the graphs also, that if it is hyper, it just diverting, just like from the standard deviation we are also looking, that if it is going so away from the mean values, then there is a stationarity problem, and we have understood that from the graph. Now in EVIEWS, there are there are icons that we can check at post level, and then we have to compare with it is this probability value. So I think she has got the idea now. You can proceed now. Thank you very much.
Yes, even from here, when we are checking from the eView, see, here I am checking the options. Okay, test for the unit root at level. Here I am instructing the eViews. Please check whether this series have unit root issue at level. Automatically, if I will collect the first, select on the first difference, so eViews automatically calculate at the first difference. Here eViews automatically calculate at the second difference. Okay, so here I'm instructing. So see, here I have export variable. I write down here at export, okay, in my table. And I am instructing to the eViews check whether this time series have issue at level, issue with unit root at level or not. I instruct the eViews, and eViews is telling me yes, it have an issue because probability value is more than 0.05%. Here I have the p-value and t-statistics. t-statistics. So I am here putting at level, I have the issue -1, 4.166, and probability value is 0.5668. Now I am instructing to the EVIEWS check same situation at first difference.
Kindly mute yourself. Hello. Chalo Puri, kindly mute yourself.
Dr. Firdaus, you can meet him.
Okay, now I have here at the first different, I instructed the EVIEWS, please calculate at first difference. So it calculated, and now it is showing its value is less than 0.05. So see here, I can here put colors for you, so you will understand better my order of integration here. So here again, I have one order of integration at level. It's mean sorry, at one at first difference, I'm writing here. It's mean at level here, and it's mean at first difference. First difference. So this is my this. Now let me proceed with the other variable. I'm not going to calculate all the variable here. I'm just showing because we have a less time. I just want to show you. Here you can see even with its graph look like in a quite balancing form. So let's check what is the level of integration with respect to its unit root at level. See 0.495. So I have import, which is import, and value is import value is okay, minus 1.5599, okay, and its p value 0.495, and here will be, and I'm going to check at level here from the first difference. Yes, it's become stationary at first difference. So 74984, and it becomes 0.000. Okay, and at level.
Hello, Professor.
So, yes.
Sir, I have a question. When you are checking it at the level, why cannot we include that trend and this intercept also select that tab?
We can select this also. There is a no reason. There is no problem in that. We can always select this. There
Does
is
that
a
have
lot of
effect on stationarity as well?
yes. It will also tell us the same thing. Okay, so intercept, trend, even none, because a lot of papers, if you will see, different kind of researcher, they are using different kind of unit root test. Even I can here select my level, and now checking here. See what I have selected at level, but I take trend and intercept, and it is still showing me the same results, that it is not stationary at first level. Let me change to the first level, and at first level it is showing me it is stationary. So it's depend on us whatever we want to do. A lot of researchers, what they are usually doing, they are even taking at intercept, at trend and intercept, at level, at first difference. So they are showing in their table different kind of estimations for the editors to just show their results. So we can definitely take this.
Okay, thank you,
Now,
sir.
now one more thing I really want to tell you, okay? But okay, after that I will explain you this. Okay, now second difference we already check. This have ish this it's going to become stationary at second difference. Yes. So if I will go to my presentation, according to my presentation, I can use ARDL estimation only when my variables are stationary at level, or I going to use my IND variable because it is becoming stationary at second difference. So I'm not going to include this variable in my estimation. But other than that, I can use my all variable in my estimation. So let's proceed with basic ARDL estimation, how we do. So, okay, first of all, what I'm going to check over here, why I'm using ARDL estimation. So I am going to check what is the impact of even I can show you my allow me a moment. I will show you my this paper. Okay, so I'm going to check what is the impact of import and export on exchange rate volatility. This is my basic how you can say basic my estimation, what I'm going to check over here right now. So my first variable is export. I select my all other variable. I am not going to include IND variable because this is stationary at second difference. I'm just going to open as like equation. And in the method, I am using ARDL estimation. I just select the ARDL estimation. So here I have my all dependent independent variables here. You can simply see here my all dependent and independent variable. Method of estimation is auto-regressive distributed lag model. And I just click on OK. So once I click here, I have all the estimations. Here you can see. So this is a regression estimation based on auto-regressive distributed lag estimation. So now I wanted to check whether my this variables have, how you can say, integrated with each other or not. So I am just going to select, I'm just going to the views. From the views, I am going to select long run form and bound test. I will send you the manual after our class so you can check all the results in the manual. So here we can see that our variables, they don't have any kind of long run estimation, long run, how you can say, co-integration. In simple words, the variables are not working with each other in the long run form. How we can select, how we can check this? We can check with the help of F bond test, F value of bond test. Here we have the F bond test, F statistics, and we can see the F statistics is not lie among those variables here. So we can simply say that there is a no co-integration exists between the variable. So now I need to change order of my variables. Order of variables, how I can select? I'm just going to show you how we can use different estimation techniques, how we can apply different kind of estimation techniques in order to calculate our ARDL estimation. So now I am going to check my this variable, this variable, this variable, this, and this. And I'm going to again open here ARDL estimation. This is my ARDL long run form. Here you can easily see that F statistics value is more than these values. In rule of thumb, here I'm going to rule of thumb. If F statistics value is greater than upper bound and lower bounds, then we can say there is long run integration. Integration means movement of variables. So this is my rule of thumb. So let's go again here. I have the F statistics 16.42. Here I have F statistics 16.42 and upper bound and lower bound. Okay, so let me take screenshots for you and then I will put over here. Okay, so see, I have here, you can simply say 16.42. This is my lower bound, this is my upper bound. Now, question arises in your mind, what is the meaning of upper bonds and lower bond? So, the researcher who invented this ARDL estimation, Pesaran, his name was Pesaran. So Pesaran calculated this upper bonds and lower bond values for ARDL estimation. And he gave us rule of thumb that if we compare our computed F statistics value with upper bonds and lower bond, and if our value is greater than upper and lower bond, then we can simply say that there is a co-integration exists among the variables. This is his rule of thumb. I will also send you the link of his paper after our session with all the screenshots. So here I can see that there is our F statistics value is higher than the upper bound and the lower bound. So we can simply say there is a co-integration exist among the variables. Now, question is, yes.
Sorry, sir, for interruption. But theory suggests that if the F statistics is greater than upper bound value, then there is a co-integration. If it is less than lower bound value, then there is no co-integration.
Yes, or definitely. You are absolute.
You are saying something different, I think so.
No. It's mean like this, that if F statistic is greater than the upper bound, you're absolutely right.
Yeah.
You're absolutely right. So upper bound means like this, I have this values. If this is the upper bound, I into 1, this is our upper bound. So if values are greater than this values, which is 16.42 in our case, so we can simply say there is an existence of co-integration. Why I say lower bound in my communication while speaking? So definitely the values will be this, my 16.42, it is eventually higher than the lower bound values also. So whenever our F statistics is higher than the upper bound values, so we can say there is a co-integration exists. And sometime our values are between lower bound and upper bound. So we can simply say that the co-integration is inclusive. So here I have my values. My values are greater than how you can simply say the upper bound. So I can say there is a co-integration exists among the variables. Now, second thing regarding long run estimation and short run estimation. Now, question is that what is long run estimation and what is short run estimation? So theory suggests values are changing over the period of 1 year or more. We say it is long run estimation. And when values are changing usually less than 1 year, we say it is short term. And some economists suggest that usually long run means when any economic policy is applied and it changes the results over 3 to 4 years. It is known as long run period, and less than 3 to 4 years is known as short run period. So now in economics we have different kind of how you can say different kind of definitions exist regarding long run and short run. Some theories suggest that long run period over the year, if any values are changing over the year, it is known as long run period. And some are saying like when they are changing over less than a year, it is a short run period. And some economists suggest that when the values are changing over the period of 3 to 4 years, so this is a long run period. And some suggest that when this is a less than 3 to 4 year, it is a short run period. So there is a contradiction exists. So if we will go into the base of any kind of economic theory, and when we are checking any kind of economic policy is applied within a certain country, so we can see the results minimum 3 to 4 years, even 5 years. So this kind of period is known as usually the long run period. And sometime when apply the economic policy and when we are analyzing their results, when we are analyzing the output within the 6 months, even within the within the period of 1 year, so we can say that this period is known as short run period. So there is a contradiction exists between long run and the short run. So now I have here the values here, these values down. These values are my long run period values. So let me take the screenshot and then I can explain you. So here I have this value, you can simply say, so I can simply say my only one variable, which is interest rate, impacting on my real exchange rate. Other than that, none of the variable is impacting on my exchange rate, because here we can see the probability values are higher than 0.05%. Here I have my probability value less than 0.05%. So I can say that whenever there is a positive change means when 1 unit of interest rate will increase, it will increase the real exchange rate with 0.342 units. So here I can see that if 1 unit of interest rate will change, it will change my exchange rate with 0.342 units. So this is my long run estimation. How I calculated, let me just explain you one more time. I have just taken my all the variable, dependent, independent. Here I select, I just go to the equation. From equation, I have just selected ARDL. Here I didn't click on the anything. Here I have my dependent independent variable. Method is ARDL. And here I just click on OK. And then I just go to the views, coefficient diagnostic. Why coefficient diagnostic? Because I'm going to check coefficient of my long run and short run. And I just click on the long run and bond test. And here it is showing my long run estimations. That's how I can simply compute my long run and short run. So let me just go and show you the now my short run estimations, how to calculate the short run. Same autoregressive. I have selected my variable. But one more thing I would like to share, that in EVIEWS, we can also change our lag selections. What is the meaning of lag? So different researchers, they have using the different kind of lags. Let me just tell you first, automatic lag selection. So with the help of automatic lag selection, maximum lags are 4. Even I can here give the 5, 6, but 4 are the benchmark. I just select the 4. Automatic, I am just instructing to the EVIEWS, whatever the best lag for my estimation, please compute my ARDL model as the best lag. I click on the OK. So you can even see here the ARDL is calculating at these lags, which are less than 4 my lags. But here I can also say to my EVIEWS that please select the automatic lags or fixed lag. Let me go for the fix. I just click on the fix. Now you can see here, I have my dependent variable lags, which is for fix. So EVIEWS calculated all the values, -1 lag, -2 lag, -3 lag, -4 lag, all the variables at lag 4, because I instruct the EVIEWS to compute my values at the fixed lag. And if we want to check that which kind of lags are appropriate for us, so how we can simply go for the var. Here I just simply run the var lag selection, and here AR graph. So you can simply say here is the AR graph, and here I can even check the table. Here I can simply check with my this inverse root. Now we have this. Okay, so now I have selected my short run. I need to compute my short run. So let me go for my short run estimations. I just select my variables for short run. Equation. I just go for my short run. Automatic, same thing. Okay, from here, this is my long run values. And then when I will click on the error correction form, it is showing my short run values. I have here the same F statistics. The one thing which I really would like to mention regarding co-integration values. Co-integration is one of the most important factor in ARDL estimation. Let me just put here. This value, co-integration. Rule of thumb. Okay. Co-integration should be less than 1 and best value. Okay. However, a lot of researchers, they told they mention that co-integration value should be less than 2. Less than 2 meaning 1.89 or 1.95. Okay, what is this value? It's mean system. System means economic system or the relationship between dependent and independent variables will become balance. Will become balance. Okay, within certain time frame which is 1 at best level. I explained you before a while ago that a lot of researchers, they explain that long run period usually based on 3 years, 4 years, 5 years. This is the period on which any economic policy is applied, and then we can have the results of that economic policy. So ECM value, error correction value, which is a co-integration EQ value as mentioned in the EVIEWS, its coefficient should be less than 1, which is at the best level. It's mean this that any system will become the balance, within the one period, within the period of 1 year, it will become the balance. Meaning, in economic system, if those variables will drift from each other, So it will again come to the point of starting, like at the starting point within the period of 1 year. That's what ECM co-integration value explain us. So rule of thumb is that it should be less than 2, best would be less than 1, and it should be how you can say, its probability value should be less than 0.00 value. Yes, Professor Firdos, any comment on this? We have a lot of paper on ARDL and ECM.
Right now, from my side, there is no comment. And if participants they are having, they can quickly jump. And I suggest you to plug charger to your laptop because it is going to be drained soon.
Okay. So just allow me 1 second. Let me just put on the charge.
Yes, it is showing very best. So meanwhile, participants, if you are having any doubt, you can always post to raise your hand instead of quickly jumping in this session. It is not it is neither accepted and not it is a good thing to
Professor Firdos, maybe tomorrow or by this weekend, I will share the, how you can see, the manual of EVIEWS ARDL from a period, how to open the data, what is stationary at first difference, what is stationary at second difference. I'm going to explain each and everything with the definition and where to click and how to estimate the values. And I will also share the basic paper. Basic papers means the famous ARDL estimation papers with the student. So I will also send you, you can send all those how you can say, all those material to the students.
Yes,
So
sure.
right now we have just how you can say 1.5 hour, and ARDL is a quite huge topic. So personally for me, 1.5 hour is so much less for it because I really need to pack this up.
Yeah.
Professor, there is a question in chat box.
Sure. Okay.
Arushi Srivastava, she is asking about p-value. If you can read.
Can you please explain again the p-value? Okay. Okay. So I can hear p-value. P-values, please keep in mind one thing. P-values is depend on our own judgment. Okay. How? I can explain you small thing. On judgment. Okay. 0.01. Okay. P-value less than 1%. Okay. 0.023. Okay. P-value less than 5%. Okay. P-value here 0.089. P-value less than 10%. Now, please focus on my words so you will understand. Okay. Either we are using SATA, either we are using R, either we are using EVIEWS. Okay. All kind of those software, they are showing us p-value, probability values, okay, which is in the built-in form. And this built-in form is based on, if I will go into the econometrics and statistics theory, so it is based on some kind of statistical significance test. In more deep way, it is based on one tail test or a two tail test. Okay. So I'm not going to the so much deep. So whenever we will have any kind of p-value, we always need to compare this p-value according to our standards. Our standards we usually select based on this criteria, whether I am comparing my p-value at 1% level of significance, either 5% level of significance, or either 10% level of significance. It's based on my own criteria. It's based on my own criteria, like which kind of significance level I am going to give. I can give you the one more small example. It will make things more clear. Let's suppose that in the short run, one thing is significant at 1% level, but in the long run, it is going to become the significant at 10% of level. So now we need to apply basic economic theory to explain the relationship between those variables. So p-values is basically based on our own judgment and own criteria in order to explain the relationship between dependent variable and independent variables. So let's see over here. See, here I have some values. Let me just go try to find out some more appropriate example, or either I can take this example. So uh, mhm. Okay, let's take example of this one. So here you can simply see, if I will just take out the values. See, here I have value, p-value, which is less than 1%. Here I have p-value less than 10%. And here I have value, this value is less than 5% and this value is less than 1%. So it's all depend on my criteria on which significance value I want to interpret my results. So here even I have some value, this down one, which is less than 5%. Here it is less than 5%. This one is less than 0%, less than 1%. So I can interpret my p-values results based on those probability value. But before that, I need to select my judgment level, my criteria of significance. Either I am going to take criteria based on 1%, either I am going to take criteria based on 5%, or either I am going to take criteria based on 10%. It's totally depend on my own judgment. But once I will select my criteria, then I really need to, how you can simply say, I need to interpret my results according to the economic theory. I must have to validate some kind of economic theory based on my p-values. Based on p-values, I must need to uh, validate my economic theory. I can give you the small example how you can need to validate your economic theory. For example, human development index always increases economic growth, always positively impact on the economic growth. But let's suppose that I have my human development index value in the negative form. So it's this kind of relationship is not going to validate economic theory. Like how we can say that the increase in human development index will decrease the economic growth. No, this is not validating the economic theory. So I can simply say there must be some problem with my estimation, there must be a problem with my calculation, with my model. So I always need to select this kind of model, this kind of estimation, which validates the economic theory. So in ARDL, probability value is eventually based on level of our criteria, on our parameters, on which parameters we are going to explain our results. I hope it's clear a little bit more. I will send in the notes, and in the notes I will explain all those things again. Now, I have here the short run. We are going away from the time. I will just explain you the short run. So see, here the value of short run always we need to select the value which is at the level. How we can say with it is at the level? Here you can see -1 lag, -2 lag. Here it is at the level. Here at again -1 lag, -2 lag. So I am going to select my values at the level. So here I have value of my export. Here I have my value of short run value of my inflation. So here I am explaining that both variables are not significant because p-value is greater than 0.05%, 0.10%. So which is my criteria. So p-values are greater than the probability value. So all these variables are not significant in the short run. So that's how we calculate the short run in the EVIEWS. We are getting out of time, so I'm just trying to explain you as much as I can. Now, in the EVIEWS, we can also calculate, we can also check a lot of other options. Okay. Some options with the EVIEWS, we can also check the Granger casualty test and stability test. I'm going to explain you the stability test now, how we can check our stability test. Same thing I am running, ARDL estimation, I just run. Here I have those values. Here I have long run form. These are my long run form. This is my F statistics. I just calculate the different variables now. And now I am just going to check my stability test. Stability in the EVIEWS, we check with two kind of tests, which is Kusum test and Kusum square test. How we can select this? Let me just go to the again take EVIEWS, ARDL estimation. I'm just checking here. Here is my long run. This is my long run. Again, go to the view, go to the stability diagnostic test, stability diagnostic. Here I am just selecting recursive estimate. I click on the recursive estimate. Here I have two kind of tests, Kusum test and Kusum square of test. So I am selecting Kusum test. This is my Kusum test. And the rule of thumb for this kind of test, this blue line, which is technically the co-integration line, we can say, the system line, we can say, it should be between those red lines. It should be between those red lines. If this blue line is outside the red line, so we can say that our system is not balanced. Our ARDL estimation is not balanced. There is one more kind of graph we can check, recursive Kusum square. So see, Kusum square is indicating that this blue line is outside the red line. So these estimations are not balanced. So technically, when we are calculating the ARDL, our system should be balanced. So this blue line should lie between the red line. That's how we can check the stability of our system. Now, more thing I really would like to catch up over here. Allow me a moment. Because we are getting out of time. Okay. Yes, the most important thing, a lot of students will face this kind of problem. I am going to, yes. So this is a small formula, this one. This is the formula for taking the log form of the variable. Why log form is important? Okay, now let me open my all the variables. Here I am opening my all the variables. Okay. If I will check my all the variables, so I can simply see over here, there is no elasticity exists between the variable. What is the meaning of elasticity? You can simply see that this value is 55, then again this value is -9, then this value is 14, then 16, then this values is in millions or billions. Okay, then this value is 23, then again this value is 9.3. So here I can simply see that there is a problem that my values of all the variables are not elastic. Elastic means when I am going to compare those values with each other, there is a problem in the units, there is a problem in the overall values. So usually whenever we have this kind of situation, in our values, so we apply log form in ARDL estimation. And how to take log form of any variable, here I am going to explain. Let me just take this variable. You can simply say these variables are really very much high variable, and I am converting those values into a log form. So I am just going into the object. I just put into the generate series. I just enter this code, but in this code I need to exactly write those variable name which I have in my EVIEWS. So here I am going to taking for IND variable, I am writing IND here. Here I also write IND. Here I am also writing IND, and here I am also writing IND. So when I will click on the OK, you will see now one new variable is appear, log IND. So this variable IND is already converted into the log form. Log form means the variable is already converted into the small units. Why I am doing this? Because I want to create elasticity among my variables. So this one, let's open as a group and compare. Now you can see over here 20.975 and this value is 1.92. So you can simply say these values are converted into the log form. These values are automatically become the smaller. I have queries from a lot of students that can we converted negative values in the log form? Yes. In the EVIEWS, with the help of these values, we can easily converted our values into the log form. I can even show you in a while. Okay, so you see, I have ERV values which is in the negative form. Can I convert into the log form? Yes, I can easily convert. Same thing. Go to the object, generate new series. I am just putting my formula. In the formula, I am just changing all those values. ERV, okay, again ERV, again ERV, and again ERV, and I click OK. See, new variable is generated. It's already converted my bigger negative values into the shorter values. Let's compare here. This one as a group. Here I can see normally it was -9 and now it is converted into -2.3. Why I am telling you this? Technically, when we are calculating any kind of estimation, any kind of model in ARDL or any kind of panel data analysis, 99.9% editors, researchers, teachers, and professors, they recommend that please convert your values in the log form. Once we are creating the log form, on that time, elasticity exists among the variable and we can easily interpret our results. So if I want to calculate ARDL for the best result, so it is highly recommended to convert the variable into elasticity form. I will share all the material, all the shortcuts, all the paper with the Dr. Firdaus regarding ARDL, and I try my level best to explain ARDL as much as I can just because of short time. That's what I can say. Yes, sir.
Thank you, Professor. Although we are out of time, but there is a one question we have left with. If you can revisit the problem of co-integration very quickly, if you can.
Problem of co-integration?
Yes, Dr. Meenakshi is asking.
Okay. What is the meaning of co-integration? Let's go to the basic. Co-integration. Co-integration. Simplest meaning. See, if I will say I have few variables A, B, C, D, if those variables they are walking with each other in a long run, you can see here I just draw some lines. Okay, here, see these lines just like a railway lines parallel. So any variable which is walking with each other for a long period of time, so we simply say those variables are co-integrating. They are walking with each other for walking with each other. This is the meaning of co-integration.
Okay.
Yes,
Thank you,
Sheikh
Professor.
Junaid, you have
Thank you.
question.
Yes, yes.
Jinesh, you can ask your question.
Hello.
Hello, yes, sir.
Yes, please.
Yes, sir. I have a question. If our dependent variable is of stationary of order first, and our independent variables are of mixed order of 0 and 1, Can we use ARDL there?
We can use. There is no problem. We can use.
Sir, but I
Just
have heard, yes, I have heard that if our dependent variable is of order 1, then we cannot use ARDL. It should be of order 0.
there is a I have also session and I also have discussion with Professor Kazi from Russia. Okay, he have a lot of papers on ARDL, and he even showed us there is a one more program. I just forget the name of that program. I will share with you in my note also. He even show us the machine language, the algorithm of ARDL, and he showed us even if the dependent variables at first different, at if it is stationary at first different, we can still have the results. There is a no problem. There is no problem at all. Only the rule of thumb is that the variable should not be integrated at level 2. It can be either 0 or 1, either it can be 1 or 1, either it can be 0 and 0. So now, basic question is that you heard about it that we cannot proceed if our dependent variable is at first difference or it is at first difference. So question is that, do we have any kind of literature proof on that from any statistician or econometrician? I don't think so. We don't have any kind of written proof or written estimation or written calculation or written formula. So definitely we can have this.
Okay, sir. Thank you, sir. And apart from that, sir, if we have to include our results in the paper, then when we copy our results in the paper, do we have to include all those variables which have lag of 1 period or second period, which will appear in the results? Did we have to
No,
copy them all?
it's depend on you. It's totally depend on you how you want to make your paper. Okay.
Okay, sir.
For example, somebody just asked me a question, sir, why you are not showing with the trend and intercept? You can definitely show with trend and intercept. Okay.
Okay.
You can definitely show with lag. You can definitely show with the diagram of lag. You can definitely show multiple of results, multiple of estimation. Okay. It's totally depend what is the motive of your paper. If you really want to make your paper how you can say paper according to the standard, so only show the relevant information according to the motives, according to your aim. Yes, you can show all kind of this thing if you are writing the ARDL paper 15 years back, when Professor Shebaz from the China, he wrote their paper on ARDL estimation based on Angola. So he was the first guy or the second guy who wrote a lot of paper on the ARDL during the period of 2012, 2013, 2014. So whenever any technique is in the, it is like a newly, how you can say, this is a newly invented technique. So on that time, you can put the multiple information, but just go with the flow. Whenever a lot of researcher, they are using similar kind of technique is becoming the old and obsolete. So on that time, you only need to put that information in your paper, which is relevant. Because if you will put a lot of other information in your paper, which is not relevant, to be very honest, editor might reject your paper. You can even have the desk rejection, because
But
this kind
yes,
of information is not relevant.
yes, sir. But at sometimes what I had seen that if a variable is not insignificant at first period, but it becomes significant after a lag. If we include like EPS, environmental policy stringency, because the policies have effect after a lag, and they become effective after a lag of 1 or 2 periods. Then did we have to include that?
You can definitely include this, and on that time, whatever you are doing, I highly recommended put this information in the notes or in the acknowledgement. put in the acknowledgement, sir, I am using this technique. I take the lag of this variable because of this reason, and my scientific justification because of taking lag is based on this criteria. And on that time, even if you will mention any reference paper who already use this kind of technique, then there is a no issue. Then even you can use this, and that paper can have a lot of citation, because you are doing some kind of work, you apply some kind of technique which is very rare in research, I would say. So if you are applying such kind of things, such kind of criteria, always mention in the notes, footnotes, or you can always mention in the disclaimer or in the acknowledgement.
Okay, okay. Thank you, sir. Got it.
There are some more questions. One question is about the log regression function of the time series.
If we
If
have
there
a
is
log regression function of time series, then there is a need to check stationary. Technically speaking, we always need to check the stationary, because stationary is the pre-requirement of ARDL estimation. If you will just go on this presentation, even here, okay, so see, stationary at level, stationary at first difference, and here data should be stationary purely at first difference or a mixture of level and first difference. Even if we will know that our data is stationary, so if you are calculating ARDL, I always suggest you go for checking the unit root analysis, stationary analysis, and mention in your paper. And if I have very much less time, but here I can even show you one more thing. There is also one more famous test, Philip, this one, Philip Perron, same kind of test. See, I just change the augmented ADF to Philip Perron test. Just click over here and see, same kind of values here you can show. So when you are writing your paper, even you can here make 2 or 3 column. Let's suppose here I will just insert above. Here I will say Marcel. Here I write ADF test, and here I can even write one more, like down, let's suppose. Here I can down Marcel. Here I can make PP. Same kind of variable, just copy here, okay, and take PP test now. So now calculate all the variables, all the tests based on Phillips Perron test. So now you can see you can have a two kind of unit roots test, ADF and PP. And when you are writing your analysis, you can write here, please see table number 1 based on ADF test and based on PP test. The order of integration is mixed. So you can explain that kind of information in your paper. It's only depend on your goals, what you want to do in your paper. Any more questions?
So we are now out of time.
Sir, last question, sir. It's very short question, sir. Am I audible?
Yes, please go ahead.
Yes, sir. Actually, I want to know what should be the minimum number of observations required to run ARDL approach.
Good question. Okay, I can tell you, I can give you the rule of thumb. Okay, if data is okay, first of all, for ARDL, data should be minimum 30 years. And I can say, I have seen ARDL paper with 25 years of data. I have seen this, but recommended is minimum should be 30 years. So if you have minimum 30 years, so your dependent and independent variable, highly recommended, okay, for 30 years, for 30 years should be 4 or 5. Okay. Okay, so you can say y1 is equals to x1 plus x2 plus x3 and x4. So for 30 year, that should be the best level. If you are increasing here, for example, 52 years, okay, which I have here, 52, here in my data set. So I can even take 6 to 7 variables. Otherwise, 6 to 7, 56. So here I can take 6 to 7 variables. So if your variables are less and your years are less, and if you want to calculate the ARDL via EVIEWS, it will show you the error regarding there is a one very famous error that there is a some kind of problem in the variable. So it will not even allow you to calculate. But there is also how you can say, there is also a technique. The technique is like this: if you will have less values, let's suppose if you will have less values, here I will try to calculate ARDL. Okay, 1 2 3 4 5. Let's go for the 9 lakhs. I think it will show me the, see, singular matrix.
This is the problem
It
for
is showing me the
this is the problem for multicollinearity.
No, it is not problem of the multicollinearity. It is problem with the lags. It is problem with the lag. I have calculated same kind of problem with multicollinearity, same kind of problem. I have the same kind of error is showing. I have the less variables, and from ARDL, I have just changing to the less lag. From here, maximum lag 2 and 2. When I change the lags here, on that time, it was not showing me the multicollinearity issue. Because multicollinearity issue is existing. Reason is that our lags are too much, and when in the backend this program is running, the variables are not, how you can say, the variables have the identical values like 0 0.003, 0 0.004, 0 0.005. This is identical value. So on that time, EVIEWS is not calculating those values. But if you will have less values, left dependent and independent variables, if singular metrics are showing, just try to play with here dependent and regressor lag. Try to reduce them. You will have the ARDL estimation on that time. This is also technique.
Thank you, Professor. Thank you so much.
Thank you, Professor, for this insightful lecture. All of the participants are asking questions. Many participants have asked the questions, and it means that the session is lively. And
If
now I
our
over
data,
to
one more question, if our data is
yes.
not stationary up to 3 differences, then what type of problem is in the existence data? So you need to convert your data into first difference and second difference. You can take the differences, then then convert it into the log, and then try to take the unit root. Maybe on that time you will not have this problem. You will not have this problem. But in the disclaimer, in the acknowledgement, please kindly put this information, and you also need to put the information that you are taking account this variable, because this variables is based on this econometrics or economics theory. You cannot put any kind of that variable which not justify any economic theory. you always need to put economic theory justification. If you are adding some kind of variable, and if you really want to add that particular variable, but your data is not significant, how your data is not stationary at first difference and second difference, and you are applying some kind of technique, you are still using that variable. So please always mention the economic theory in your paper. If you are mentioning that economic theory, then you can have a lot of citations. Then other researcher will say that this particular, for example, Ms. Jaspreet Kaur, they have used this kind of technique in this their paper, so they can even cite you.
Yes, Professor, thank you very much. For you can now, off your screen, and Jaskaran, you can continue.
Okay, thank you, thank you. As I'm saying that the session is quite insightful and lively because many of the participants were asking questions because professor was explaining the ADRL model with giving example. Professor, just a request from my side is that as you are already said that you will share some data as well as some results, data with results, because most of the researchers sometimes find problem that they have the software and they learn from any workshop or tutorial, but they don't have the idea how to explain and how to go with the data when they are using some kind of software. And if you will share those the data which we can use while using this software, and it will be quite helpful. And
I will
thank
send
you.
the data file.
Yes.
I will also
Yes.
send the screenshots. I will also send this log formula, because log formula is quite new. A lot of a lot of professors, they don't have this log formula. Okay, I will also share this log formula with you, how to run this log formula. So yeah, I will share
Yes.
every material on this weekend. So
Yes.
Professor Firdos will send all the materials.
Thank you. Thank you for this strategy, Professor. Thank you. Now I over to Dr. Firdos.
So at the outset, I would request Professor Lee to open his camera and stop sharing while I will be giving vote of thanks, and while we are also going to capture some photographs also. So yes, and everybody who is in a position to open their camera, they only open. People who are lying on the beds and all, they are requested, please don't open your camera. Simultaneously it is going on recording, then it is disturbing our video. So be sensible, don't open videos when you are not in a position. So I encourage all people to open your camera and have some photograph. So Professor, you can set up sharing right now so that we can appear on the big screen. Yeah. And if you are able to open your camera, that would be great. Yeah, thank you very much. Just a moment. So sit with me, let us have a vote of thanks again, then we will capture more. So actually it was our 7th day. Good evening all participants. On behalf of Joint Economic Association, I would like to extend my deepest gratitude to both Professor Laeeq from Poland and our esteemed moderator, Dr. Jaskaran, for delivering such a wonderful and insightful session on ARDL model analysis via EVIEWS software. Professor Laeeq, as we have met so many times in different workshops, your expertise and ability to convey, such complex concepts, starting from, the basics of stationarity, level 1, level 2, and all in an accessible manner, you have greatly, enriched our understanding. And your detailed explanation and practical demonstration have provided us invaluable knowledge and skills that will undoubtedly benefit our research and analysis endeavors. So, our moderator, especially Dr. Jaskaran, you have played a significant role for guiding the session smoothly and enriching all the participants were engaging and had their questions addressed. Your facilitation played a critical role in making this session interactive and productive. So I appreciate you because you were one of the best moderators till now, and you were quite active and all in line. So we are truly grateful for the time and effort both of you, Professor Laeeq and Dr. Jaskaran, of your invested in making this session a success. The contributions are greatly appreciated, and we look forward, to applying what we have learned in our future work. Thank you once again. So please, stay for a while. I am just capturing some pictures. So we shared on, Facebook page and LinkedIn page. You are all requested. If you are not following our Facebook page or LinkedIn page, you can follow us. You can, repost. You can share your comments and feedback there. So with these words, I am thanking you for your patience. So thank you very much. Thank you. We can now leave the session. So we will meet tomorrow. 55 participants are there. We are requesting everybody kindly leave because we have to wind up the session. तो क्या किधर आ?
One charge, Andreas.
One second. Special होता है?
Moderator
थोड़ा है. तो मेरे बुखार मुझ में बोले ये कहीं बुखार मुझ.
Sas कहते हैं
Roshandan.
English, please, English.
So it is our local language we are speaking. So we have requested all the participants to leave. So if you wanna, interact, you wanna share something, you can. But yes, we are concluding the session. There are 43
we have already
participants.
ended our session, so we are just waiting to leave because we are not able to end the session until all the participants are not leaving.
So there are 39 participants. You are requested kindly leave the session. We have already done for today. So all the participants you are requested, kindly leave the session as soon as possible. Unless I have to do it manually, and that takes so much time. So I can name Arshid Patel. Can you leave? Altaf Hussain, Amrinder Kumar, Anita Behra, Deepika Sharma, Dr. Jyoti Shukla, Dr. Parveen Kumar Sahu. All are requested, to leave the session. We are done today. I think they have just kept the.
Karaoke होता है important निम्न शायद करता है.
संजय काम कर रहा हूँ.
वो रोज में.
Where are you session? Please also remember that the body to आवाज.
नहीं आखिर होता सब ठीक जो बकार गणित लिए हाँ तो मैं क्यों नहीं करते ठीक ठीक